Hello, pre-calculus class. Today I'm going to go over Chapter 8, Section 5, and this is solving more difficult trig equations. It's going to be similar to solving trig equations, which we did a few sections ago, and, except they're going to be more difficult. And you'll see why here in a minute, hopefully. So I'm just going to go through some examples just right off the bat. There's really nothing to go over except going through problems. We're solving for either x or theta, depending on whether it's radian. X is radian, theta is degrees. It is limited to between 0 and 2 pi. When it's radian, it's going to be 0 and theta. Sorry, 0 and 360 if it's theta for degrees. But rather than having like the problems that we had been doing would be something maybe similar to 4 cosine x minus 1 equals 0. You'd solve for cosine of x by adding 1 to both sides, dividing both sides by 4, and then you'd have cosine of x is equal to something. And then when we do the trig part of it, once we have cosine of x is equal to, or the trig function is equal to, we do the trig part, where we find the two quadrants, the solutions in the two quadrants. There'll be two solutions, there'll be two solutions in two different quadrants for each trig function. Well, what makes this more complicated is this cosine is now squared. So that was how it was working before. But in this case, cosine is squared. That makes this a little more complicated because when you try to solve this for cosine, you're going to have, well, let's go find out what happens. Add 1 to both sides, divide 4, and you get the cosine squared equals 1/4. Okay, the only difference between this and a simple trig function is this squared. But that's a big difference because to solve, this isn't solved for cosine if it's cosine squared. We can take the square root of both sides to solve this for cosine. When you do that, you got to do plus minus, okay? Because remember, if you have x squared is equal to 4, so x squared is equal to 4, both 2 and negative 2 is a solution for that. Both of those go to a positive 4. Same here. You have to do plus minus square root of 1/4. The square root of 1/4 is actually 1/2, but it's positive and negative 1/2. So we're going to actually break this into two branches. We're going to have cosine of x is equal to positive 1/2. Cosine of x is equal to negative 1/2. So we're going to do the trig solving that we've been doing in the solving simple trig equations. For each of these, we're going to do that whole process of finding the solution in two quadrants. We're going to do it for cosine of x equal to 1/2, and then we're going to do it for cosine, and we're going to do it again for cosine of x is equal to negative 1/2. There's one step here where we actually, once we have the cosine of x is equal to 1/2, we solve that for x by taking cosine inverse. So we're going to take one of these at a time. I'm just going to take one of these at a time. I'm not going to keep branching it because it's going to be a lot of work under each of these branches. So I'm going to start by just looking at the first one. X is equal to cosine inverse of 1/2. Okay. So we are looking at cosine. It's equal to 1/2, a positive. Cosine has solutions that are positive in 1 and 4, quadrants 1 and 4. Okay. So quadrant 1 solution. We're going to take cosine. Let me go ahead and do this in the calculator. Clear that. Mode is not in radian. We are in radian. We're doing a radian problem here. Quit out. I'm doing second cosine inverse, or cosine for cosine inverse. 1 divided by 2. We get 1.047. That's a radian angle measure. 1.047. And that's my first quadrant solution. That is also my reference angle, because first quadrant solutions are reference angles. Okay? Fourth quadrant. The fourth quadrant reference angle formula is alpha is equal to 2 pi minus x. I'm taking my reference angle value, plugging it in for alpha, and solving this for x. Okay, 2 pi minus 1.047, using the approximately equal to whenever you insert an approximated value. And 2 pi minus that value is 5.436. So that is two solutions. I have two solutions now. I have this value here. Let me switch to a pen real quick. So I have this value here as a solution. This value here is a solution. but also it's important to have the reference angle handy. Okay, so I want to do the hand so I don't actually not a cursor blinking. Excuse me. But that was just one branch, so we have to do more work, or we have to do. We're not done yet. That's what I'm trying to say. I'm not done yet. X is equal to cosine inverse of negative 1/2. Okay. Well, this is cosine. It's negative. When cosine is negative, there's solutions in the quadrants 2 and 3. All right. Well, we're dealing with cosine, both of these. One situation is positive, one's negative, so it makes sense that it'll be the two quadrants not covered in this first part that we did, the first branch that we did. So we're doing that in the second. The second branch will be the two quadrants that are not covered in the first branch. Makes sense? Also, very, very noteworthy in this case, they're both equal to 1/2. Okay, which means they have the same value except for the sign, which means they're going to have the same reference angle. So we can use this reference angle that we found in quadrant 1 to find the solutions in quadrant 2 and 3. Hopefully that makes sense, because it's 1/2 both times. It's 1/2, and remember the reference angle is used for the decimal value, not the sign. So we don't have to find the reference angle again, but you can if you want, because if you type in cosine, if I type in cosine, actually I want to do this, cosine of negative 1/2. I'm gonna go through a long process. So that's 2.09. What quadrant is that in? You find that out, then you use the reference angle to find alpha, but you don't need to do all that because we know what the reference angle is, because it's going to be the same reference angle for positive 1/2. The reference angle for negative 1/2 is the same as the reference angle for positive 1/2. That's my point. Hopefully that makes sense. So I'm just using the quadrant 2 solution, or sorry, the quadrant 2 reference angle formula. I'm plugging in the reference angle value for the alpha and solving for x, and that involves subtracting from both sides, moving the x over, making it positive, and subtracting that from both sides. And what do you know? You get the value that you'd get when you plug this into your calculator. There's just no need to find the reference angle from this at this point. Does that make sense, I hope? So this is my third solution. Okay, and then we use the last reference angle formula that we haven't used yet, quadrant 3 reference angle formula, plugging the reference angle in. In this case, solving for x, it involves adding pi to both sides, and then we get our final value. Final value. We have 4 solutions for this, 4 solutions. And what does that mean? So these are all approximated, but that means that if I go back up to the original problem, I should be able to plug any one of these values into 4 cosine squared minus 1 and get 0. 4 cosine squared minus 1. Let's see if I can remember that. 4 cosine. And let me pick one that's over here that I can see. 4.819. I'm already in radian mode. And I'm going to square that. Okay, that's taking that value times itself, and I think I had to add 1. Is that what it was? What do I need to do? Minus 1. You just subtract 1. That's still not going to be quite right. Maybe it's because I'm not squaring it correctly. Let me try, because this should work. Let me try it this way. I'm going to do cosine 4.189. This is in radian mode, so that should give me a value. Okay, I'm going to take that value, answer. I'm going to do 4 times second answer squared minus 1. And what I get here is actually this e to the negative 4 is what is important, because that means you move the decimal point 4 places to the left. So this number is actually negative 0.0007. So that's pretty close to 0 total. And that's an indication that we did get something, we got something that is close to, and it's because it's approximated is why it's not exactly 0, but is close to a solution of this value here. Okay, so hopefully that made sense. Apparently you can't put a squared after a cosine. Apparently that didn't work. So I took cosine and I squared the value that I got after evaluating for cosine, and then put everything else for that equation, and that's what I did there. Okay, example 2 for this. All right, so I have here solve 2 sine squared x plus, or sorry, let me start over. Solve 2 sine squared x equal to sine x. We're in radian again, 0 to 2 pi. And here is what you do not want to do, would be incorrect if I was in class and I had a board, I would write this down. You cannot cancel out a sine from both sides. Because if you did that, if you ever cancel out a variable, and that's what you would be doing, you'd be losing a variable by canceling out sine from both sides. You would get to sine equals 1, but you'd be actually losing a solution in the process. You'd remove a solution from the problem. It would, and that is, yeah, that's a problem. You're not going to get all the solutions. So what you need to do in this case is you need to factor. So we're going to subtract the sine x from both sides, which gives you a 0 on the right. You have 2 sine squared x minus sine x, and we can factor out a sine x in common in both of these, okay? Pulling that out. So if I pull sine x out, I'm left with 2 sine x minus 1. And here I have a product of two things equal to 0. Zero product rule says that I can set each part of that whatever's separated by the multiplication, I can set each part equal to 0. And that's what I'm going to do. I'm going to set sine x equal to 0. I'm going to set 2 sine x minus 1 equal to 0. So by canceling out, the thing that I told you not to do, to change this to 2 sine x minus equals 1, you would still get this branch, but you would lose this branch by canceling out. And that would actually lose a solution. So what we have going on here is we have two branches. One branch is similar to what we just did in the last example, but this branch here, sine inverse of 0, is not similar because it's a solution not in a quadrant. Okay? When dealing with radians, quadrants end at, or begin and end at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, 0 is one of those. 0 is not a solution in a quadrant. But sine of 0 is 0, so you do get a solution. Sine of 0 is 0, and the other place that sine is 0 between 0 and 2 pi is when sine is pi. Okay, so sine of 0, we're in radian here, is equal to 0. Sine of second pi is also 0. So there are two solutions between 0 and 2 pi in which sine is 0. 0 and pi. Okay, but they're not in quadrants, so the quadrant reference angle formulas won't work. If you think of sine and cosine, I actually think I'm going to jump back to the curves, the graphs of the curves here. The parent function of sine, this is the graph of 0 to 2 pi, starts at 0, and then it goes up. It's going to be 1 at one value, okay? But it's going to be 0 at two values. It's going to be negative 1 at one value, okay? Now 2 pi is at 0 also, but we're not going to include that, and I'll show you why in a minute. But between 0 and 2 pi, including 0, not including 2 pi, sine is 0 at two values. And you just need to know this. There's no reference angles for you to find this. Same with cosine. The parent graph, if we have cosine, there are two values at which it's 0, pi over 2 and 3 pi over 2. Okay? So also 1 and 0 are also, when you have a trig function, or I should say sine or cosine equal to 1 or 0, that'll also be between quadrants. But for 1 and negative 1, I mean to be saying here. Okay, so let me start over. When you have the trig function equal to 1 and negative 1, you'll also have measures that are between quadrants, but there's only going to be one value for those because it only goes up to 1 once, and it only goes down to negative 1 once. Okay, it only goes up to 1 once, and it only goes down to -1 once, but it goes through 0 twice. I'm hoping that makes sense. But what I wanted to say... why didn't I include 2 pi? Because if you'll notice, the keen-eyed would have noticed that any time I give these, I always say 0 less than or equal to x, strictly less than 2 pi. Okay, so we're including 0, we're not including 2 pi. Why would that be? Well, 0 and 2 pi 2 is a repeat of the entire cycle. So if I included 2 pi, I'm actually going over one full rotation by just a very slight amount, because 0 and 2 pi are equal. You have to go all the way to 2 pi, not including it. If I include 0 and 2 pi, then I'm including a little bit more than a full cycle, because I went a little bit over, included a value that's repeating. So if what I'm trying to say is those are coterminal, and once you include 2 parts of coterminal, it's more than 1 revolution. I don't know if that's making sense. Please email me or send me questions if I'm not making sense here, but 0 and 2 pi is actually starting to repeat a full revolution. Okay, so we never include 2 pi. I shouldn't say we never, but I don't include 2 pi with 0 because they are the same. Okay, hopefully that's making sense. So that's why 2 pi is not included in the solution, while 0 and pi are, and 2 pi is value plugged in will give you 0. But it's not included because we're doing strictly less than 2 pi. The other branch, sine inverse of 1/2, is actually going to be like we've been doing it. It's going to be like if you were just given this as a simple trig equation to solve. So solutions for sine positive are in first and second quadrant. Do sine inverse in your calculator. You're going to get a value 524. That's also our alpha value. The quadrant 2 reference angle formula is alpha minus pi, or equals pi minus x. And then we plug in, I see that I glossed over the fact that sine of 1/2 is pi over 6 exactly. I did the approximation here. You can plug in the exact value or the approximation, but you just got to make sure you're doing approximations then. So we have exact values, we have approximate values, which would be okay as long as you do approximately equal to. And that gives us 4 solutions also. 0, pi over 6, 5 pi over 6, and pi. To test these values, let's say 5 pi over 6, to test this value, I should be able to plug. So I'm going to do sine of pi, sine of, I want to do 5 pi divided by 6. I'm going to get some value, 0.5 actually. I'm going to get 0.5, a clean 0.5. Okay, that's what I get on the right. So 2 times that answer squared should be the same thing, 0.5 on both sides. So I plugged in 5 pi over 6 here and here, and I got 0.5 on both sides, so they're equal. That's just me testing that that is correct. You can test all the values if you want. 0 is pretty easy to see that that makes sense. 0, sine of 0 is 0, so you get 2 times 0 squared, which is 0. Sine of 0 is 0, so you get 0 equals 0. Okay, so that's example 2. I have a few more examples, but I'm going to break this video up into a couple parts. So again, as always, let me know if you have any questions. These are definitely more difficult. You're getting 4 solutions rather than 2, and you're going to get more than 4. You're going to get maybe 3 solutions. It'll just depend on the problem. Thank you, and good day.